Great. Thank you, Frauke, for including me in the session. Let me get my little pointer here. So yes, I'm happy to be here presenting with you all today. Somewhat surprisingly, I'm not in the program, but Frauke added me in, and I'm thrilled to be here. My background, as Frauke mentioned in the introduction, is in survey research. I'm not a computer scientist, but I have a lot of experience collecting data from people and firms and so on. And I worry a lot about data quality and the social construction of data. And so I want to talk about that angle here in the data science world. I'm sorry, Rain, I'm not sure exactly what box that is, but you can tell us later. So I found this paper published by a group at Google, and I love the title of this. And this title actually comes from somebody that they interviewed for the paper. And everybody wants to do the model work, not the data work. And I think we see this a lot, just even in the popular press or about, as data scientists talk about their work. There are these fixed data sets, and the competitions are all about who can get like a little bit more accuracy in predicting cats versus dog or pickles versus hamburgers or something like this, right? It's all about the accuracy or some accuracy measure and improving that from 94.2% to 94.6%. And that's certainly really important, and I can't do any of that, so I'm impressed, right? But my concern is that in those discussions, what's left out is, wait, where does this data come from, right? It's very much the old statistical problem that the students are given like very clean data sets and then don't know how to work with real world data. I think we're replicating that mistake again in the data science world. And so the data scientists are too often unprepared to collect their own data, which of course comes up much more often in the real world than it does in the data science programs. And so can improving the data actually also lead to better accuracy? I just saw this talk by Andrew Ng. I've adapted this from his slides here, where he's looking at the baseline model accuracy. In that first column, it's 76%. Improvements to the model, like a lot of time grinding away, changing the parameters, led to no increase in the improvement of the model's accuracy, but improving the data led to a very big increase, so 17 percentage points there in the last row. And in different cases, that varied a little bit, but improving the data was always a good approach and always gave you additional improvements over improving the model. So I think, this is going to be a very helpful way forward for the data science community, thinking about model accuracy, thinking about measurement error. So a lot of my research has been in measurement error. And what I mean by that is like the labels and the features in the data sets are wrong. We know a lot about measurement error in surveys. And to me, a lot of the coding that is done by annotators, and these might be in-house subject matter experts, these might be crowd workers, a lot of the annotation tasks that they're doing look like web surveys, right? So this is an example from a book that I really like, just read by Monarch, called Human in the Loop. And he talks about how to structure these tasks. And so this is an image and a task that he uses as an example throughout that book. It's a picture of a person standing next to a bicycle, right, and pushing the bicycle along. And the task for the annotator is to code whether this is a pedestrian, a cyclist, an animal, or a sign. Well, just physically, this looks a lot like a web survey to me. We might be asking somebody about their age category or their education level, right? Structurally, it looks a lot like that. But it's also like not very straightforward what the answer is here. And so I think this is a really nice example to think about measurement error in training data. So from surveys, we know that there are often wording and order effects. I'm not going to go into these because I don't have the time. And I think a lot of the audience members know about the very subtle changes that we can get in our very subtle changes in questions can lead to big changes in the data that we get in surveys. The question order, the response scale order, and so on. And I think we could see that here with this example, right? Maybe it's unclear, in my opinion, if this is a pedestrian or a cyclist, but maybe if pedestrian is the first choice, you pick that one. Like that's the first reasonable answer choice. But if cyclists were first and spelled correctly, maybe you'd pick that one instead, right? So I think we could see some of these subtle wording and order effects here. And a lot of these wording and order effects from the survey world may carry over into the machine learning data science world. We need to do that research. We need to figure that out. Not all effects, of course, but I think a lot of these will replicate, and we need to look into that. A lot of my research too has been about motivated misreporting, which is the idea that respondents catch on to how a survey works and start to change their answers to make the survey experience shorter. So for example, these questions from the consumer expenditure survey, the interviewer is in gray with the blue balloons and the respondent is in black with the green balloons. And the respondent may realize after 10 or 15 or 60 minutes. If I start to say no to these have you purchased questions, I can make this whole experience shorter by skipping over those follow-up questions, right? And we've shown this robustly across countries and modes and topics. So this is a robust finding in the survey world, but I think the same kind of thing can happen in the annotation context, in the training data labeling context. So this is an example from RTI a few years ago. We wanted to code, I wasn't involved in this work, but RTI wanted to code whether tweets were about marijuana. So here's a tweet that the annotators were shown. I really think some weed brownies would do my grandma good for her aching joints. And then the coders were asked, is this tweet about marijuana? And you say yes or no, but if you say yes, it pops up additional questions. Is this tweet about sleep as it relates to marijuana, about pain, about nausea? So this has a very similar structure to those consumer expenditure surveys questions we just looked at. And so again, here we might see that people start saying no to that first question, is this tweet about marijuana, to get to try to make this experience shorter and to really increase the hourly wage, to be honest, right? So that's another topic that I think we need to look into. I'm not aware of anybody who's looked into that in the data science context. And then the last example I'm going to give here of us finding from survey research that I want to look into in the data science world is about anchoring effects, or what I would call confirmation bias. So Frauke and I did some research about confirmation bias in housing unit listing, where field staff were out in neighborhoods updating address lists in the field, and they should they have an address list. Excuse me, wipe my nose. They have an existing address list from the post office, and they should add in units that are missing, and they should take out ones that are no longer there, right? And we found that the field staff become too trusting of the list, and they tend not to add the addresses that are missing when we built in known errors, and they tend not to take off addresses that we just made up. So this is an example of confirmation bias, or too trusting of the list. And we do see exactly this kind of thing in the training data as well. Here's another example from the Monarch book. I know this is a little small. It's a translation task. And so the first box says the E. coli outbreak was first seen in a San Francisco supermarket. And the annotator should then translate that into Spanish. And so in the first box here, this is unassisted, just free form text. Please enter the Spanish version of this sentence. Another way to do it would be to have like predictive text. So as soon as you enter a couple of words, the predictive text starts suggesting words. We see this on our cell phones, right? Another opportunity or another approach would be predictive annotation. So you'd show a translation, a possible translation for that sentence, and the annotator would go in and fix it, right? Maybe change some of the endings or change a couple of the words or the spelling. And then a fully automated approach is just to say, here is the original sentence in English, here it is in Spanish, is this correct, yes or no? And I think we're going to get really different answers depending on which of these methods that we use, right? And there is some research on this topic in the data science literature that I need to learn more about, but I would also like to jump in and contribute here. So when I have talked about this kind of thing with data scientists, a lot of their, no, sorry, that's a different slide. So I think I think data scientists need to have a better understanding, in my opinion, of the causes of error. So not just looking at like, what is the agreement level across the annotators, but really thinking through where are these disagreements coming from. That Andrew Ng talk that I mentioned earlier, he doesn't have a measurement error model. Here's just a very simple measurement error model where the observed value is equal to the true value plus some error. But as he's talking about the kind of errors that he worries about and he sees, it sounds like he's assuming that the errors are distributed normally with a mean of 0. So he's really just concerned about the variance. Like the answers can be all over the place and there's a lot of extra variance in those responses. And that's definitely true, but I also worry that there could be some bias in these answers. If all of the tasks are ordered in the same way and we see these sort of boredom effects or motivated misreporting, we may see all of the annotators making the same kind of errors towards the end of the process. And so I worry that the errors are a little bit more sophisticated than has perhaps been recognized by some of the researchers in the data science side. Also, the pushback I often get is like, oh, we don't worry too much about error. We'll just use a majority rule. We'll just have 5 people code every tweet and we'll take the majority there. And that works well if we can have agreement across different coders. But the assumption here, when you're doing this kind of math shown on the slide, is that the errors are independent, right? Whether I make an error in coding a given tweet is completely independent of whether you make an error or Frauke makes an error, right? But in fact, some of these things I've been talking about, the order effects, motivated misreporting, anchoring, imply that the errors are not independent. And so therefore majority rule may not be the correct approach. And so I think a more sophisticated understanding of measurement error could really help out the data science community here. So to conclude, the data science community has a lot of like really cool tricks up its sleeve, right? They are building models to predict label accuracy. They're building models to create label data. Their solution is like to problems in the training data is like more machine learning or more artificial intelligence. And all that stuff is really neat to read about. But I think we might want to take a step back and design the annotation systems a little bit better to make it easier for the annotators to just simply give the correct answer in the first place, right? Before we get into fixing the models, using extra models, like let's just collect the data better using what we already know about how to design good web surveys. And I think that data scientists should be as careful about their data as they are about their models. Thank you.